All right, so here I'm just going to kind of make sure we do have all the right information. So you should have already seen your student peers presentations on these graphs. So here's the linear. Let me focus on that one first. And we have our function, the table, the values. Make sure that all of this is what you have in your paper. Okay, domain and range, the extrema. I'm not going to go over any of this because you should have already seen it in those videos. Okay. The ones I do want to go over are these last three. So the end behavior is pretty much what's happening on the left side and on the right side in terms of y. So this right here, this just means as x is going to the left. So on the left side, what is y doing? Well, if we look at the graph for the line, okay, so right here, on the left side, we have, I can't highlight it, but on the left side, it's going down. So it would be negative infinity. On the right side, it's going up. So it'd be positive infinity. And that's exactly what we have here. Okay, so left side, negative infinity, right side, positive infinity. Applications are direct proportion and unit conversion. Okay, for the absolute value, same thing. Make sure you have all this information. Like I said, you should already kind of have this from your peers. This notation for domain and range might be a little bit different. So as long as it means the same thing, it's fine. So if all you have is 0 to infinity, with the bracket, you are good to go. Okay. So all this, pause the video where you need to if you need to fix something, and make sure you do fix it. Make sure all your answers match. Okay. And behavior is at the bottom. We have on the left side. So the left side, the graph is going up, and on the right side, the graph is going up. That's what these notations mean. And if we look at our graph, we can see that it's in fact going up on both sides. So forever up infinity, forever up positive infinity here as well. Applications are magnitude, speed, distance, length, etc. Kind of like a physics stuff here. Okay, let's go on to the next one. So we have a quadratic. Okay, so this one we have a parabola, and there's all the points that go with it. Notice that we do put the arrows. I didn't mention that on the other one because I know some of the graphs were stopping at these points. Just because we only have these points here, guys, doesn't mean the graph stops. It goes on in some direction, okay, forever. So with that in mind, here's all the information, our domain, our range, okay, the minimum, concavity, etc. I'm going to go down to the left and right end behavior. We have on the left side, so that's what this means, as x approaches negative infinity. On the left side, y is up, and on the right side, y is also up. So we have positive infinity because this graph goes up forever on both sides. This one has a whole bunch of applications. So we have several things listed here. A lot of them are, again, are physics applications, gravity, acceleration, etc. Okay. Then we have our square root. So same thing as before. Have some values. Notice that this one stops at 0, does not go to the negative side because you cannot take the square root of a negative number, not if it's a real number. Okay, then we have all our properties here. Let's look at the end behavior. On the left side, there is nothing going on because the graph stops at 0. So there is no left end behavior. On the right side, we have the graph going up slowly but surely. So it's going to go up to positive infinity. Applications, it's directly tied to quadratics, which is the one right next to it. Okay, we're halfway done. We have our cubic function, really similar to the cube root function. Okay, and these are the values. These are the properties. Again, I'm just going to kind of scroll through this because you should already have something similar to this. If you do have anything different, make sure that you correct it. Okay. For the end behavior, this graph is kind of going left and right, but it's also going down and up, one on each side. On the left side, it's going down, so that'd be negative infinity, okay, for the end behavior. On the right side, it's going to positive infinity. So we can see that here. Again, the left side is going down, the right side is going up. Applications include aerodynamic drag, regression, and interpolation. Volume. This kind of goes a little bit into calculus. So if you're interested in that, you might see some of these. Moving on to the cube root. This is the inverse of this guy. Notice the curves are really similar, except this curve kind of goes a little more sideways, but it's still going up at an angle, just a little bit slower. So here are the values. Make sure they match. We have all our information. Okay, again, make sure all these values match. You need to pause the video, go ahead and pause. For the end behavior, it is the same as cubic. Even though it is going at a slower rate, the left side is still going to go to negative infinity, and the positive side is still going to go to positive infinity, as we saw here in the graph. Down on the left side, up on the right side. Applications, solving cubic applications. So again, these two are tied, just like the quadratics and square roots are tied together, cube root and cubic are tied together. The last, actually we have a few more. So we have these two now, okay? This is the exponential. We went ahead and used e to the x, but basically you can use any base that's greater than 1. So we decided to use e because, well, why not, okay? It's one of those irrational numbers. These are the values, okay? Properties. And again, make sure if you have anything different, go ahead and change it on your paper. For the end behavior, this is a little bit interesting because on the left side, the graph actually doesn't really pass the x-axis. So it gets closer and closer to 0. And I believe the video that we did show mentioned this, so they were spot on that, okay? On the right side, the graph is going up forever. So again, going back to our graph, we can see here that this side, the left side, is getting really, really close to this dashed line here, which is actually an asymptote, okay? And it's never going to cross it. So the value of y on this line is just equal to 0. And on the right side is just going up. So that would be positive infinity. Applications include population growth, temperature change, charging, discharging rates, etc. This has a lot of application with bacteria growth as well. So lots of different behaviors we can see with exponentials. And we have the inverse of exponentials, which is a logarithm or logarithmic function. And this one looks kind of like sideways version of this guy. Okay, so there are our values. Notice that this one does not cross 0. Okay, so keep that in mind. Here are some of the properties. Make sure you check with your paper and that these are all the same as what you should have already written down. Okay. The end behavior, this one on the left side is none because there's nothing going on the left side. We have no negative x's at all. So we really can't say as it goes to negative infinity, okay? It stops at 0. And the right side is going up. Now be careful here because if you look at the graph, it kind of looks like it's leveling off, but it actually is still increasing very, very slowly. So the right side would still be going to positive infinity. Okay, left side, it gets stopped here at 0, so there's nothing going on there. Properties involve solving exponential applications because it is the inverse of exponential, and they are directly tied together. I believe it also has to do with you can measure earthquakes using logarithms as well. So that's something else if you're interested in. You're welcome to look up. The last two functions are the rational and rational squared, also known as a reciprocal function. So let's look at the rational one first. Again, make sure all your values, there we go. Make sure that all your values match. Okay, they should be okay. You just want to double check. Make sure that you pause if you need to. Domain and range, pretty much everything except for 0. Okay, because we have those asymptotes there in the middle. More properties. Okay. And our end behavior. So on the left side, this graph is getting closer and closer to that middle line again, which happens to be 0. On the right side, it's also getting close to that middle line, which happens to be 0. So if we look back at our graph, you can see that happening here. If you look at the -4, if you look at the graph, it just goes on and on and on and on, really, really close to the x-axis, but never actually crossing. So it's getting close to 0. Same thing on the right side, but now it's going the other direction, but it's still getting close to 0 when you consider the y values. Okay. Let's see, applications for this. Inverse proportion, okay, and all this other stuff right here. I'll let you read it. I'm not going to read it to you. And finally, one that's kind of an extra one, but it's good to know, the rational squared or reciprocal squared. And it looks really similar to the one before, except that this time both curves are on the top. Okay, so just keep in mind that for the range, this is going to change the value. So we're only going to go from 0 to infinity as opposed to our real numbers. Okay. And actually, this part is wrong. So you make sure that for the range here, you have that it's from 0, okay, from 0 to infinity. I believe the video you saw did get that right. So that should be fine. Okay. I'm going to scroll down to the other properties. Everything else is correct. Our end behaviors, it behaves very similar to the one before because both curves are getting close to the x-axis, which is 0. Okay. And then where we have some applications. And that's it, guys. That's a quick view of all the parent functions. Make sure you do have all of these copied down. I'm going to be checking these sometime this week, if not next week. And I might count it as another test grade just to kind of give you guys a boost in your grades. But make sure you have it. Thanks.